I'm Anil Kumar. Welcome to my series on complex numbers. We'll now see how to write a complex number correctly in modulus argument form, which is also called polar form, right? So that is the exercise for you. A complex number in polar form, which is same as modulus argument form, is written as r cos theta plus I sin theta. Write the following in correct polar form, right? Now, these four questions, you will notice that negative is there somewhere or the other, right? Now, you have to write in this form, r cos theta plus I sin theta. There is no negative here, right? Now, here when we are saying alpha, you should take alpha as something which is in between 0 radians to pi by 2, right? So, alpha is the acute angle. So, that is what alpha is. Now you need to write them in correct form, that is no negatives anywhere, when you represent the complex number in polar or modulus argument form. Is that clear to you, right? So you can pause the video and answer this question. Now I'll show you a strategy to do it, right? This is a very important strategy. Normally students struggle with such questions, but after looking at this video, it will become very, very simple. You remember that as far as the four quadrants go, all are positive here. Sine is positive in quadrant 2, tan in 3, and cosine in 4, right? So that is how it is. So forget about the real and imaginary part for the time being and just focus on this. We are saying cos alpha minus I sin alpha. That means we are looking for a complex number which in Argand diagram will be represented here, right? So that becomes an Argand diagram. Where this part will be real and that will be imaginary, correct? So when we say alpha, alpha means we are looking for this alpha, correct? Now, we don't want this negative sign. So how can we write it? That is what you have to decide. Is that clear? So you could actually, looking into this, we could say this is minus alpha, correct? Is that clear, right? So we could write this as equal to square root of 2, right? So square root of 2 times cos of minus alpha minus I sin of minus alpha. Now minus, that becomes positive since I have written sine of minus alpha. Sine of minus alpha will be negative, so you'll get the result. Do you understand? So we have written it in the correct form. All these things are positive. The argument could be anything, right? Does it make sense to you? So that is how you should be writing, right? So with this concept, move forward and write down rest of these answers. The second one is minus outside itself. So we can think about it like this. 5 times minus cos alpha minus I sin alpha. Is that clear to you? Now we need to write with all these positive. Now this says that you're looking for something which is now both are negative. That means you're looking for this position, right? Alpha is right there, correct? This is your alpha, right? So how do you go to this position where both are negative? Only if you take away alpha, you get the answer, right? So if you do minus pi, then you get the correct form. Perfect. So therefore, this should be written as equal to 5 times cos of alpha minus pi, right? So alpha minus pi plus I sine of alpha minus pi. Is that clear to you? That is the correct form. If you write with these negatives or that one, it is incorrect. So I hope you got the concept. With this concept, I like you to answer the other two questions, right? So let me do this. We will follow this strategy. So this should be written as what? 2 times what? Cos is negative, that means let's again go back to our basics. Cos negative, sine positive, that means we are talking about this position, right? So if alpha is here, right, and we want to make it here, then what? That is pi minus alpha, right? So this angle will be what? This angle will be pi minus alpha. So that becomes the argument, right? So that becomes the argument. And so you can write this as cos of pi minus alpha plus I sine of pi minus alpha. Is that clear? That is your result. The last one. Well, negative outside. So what are we going to do? We are going to write this as negative inside, right? So we get negative cos of alpha plus I sine alpha, right? So that is exactly as we did just now, right? So you can write this as no need to put brackets since r is 1, right? R is 1. So we could write this as cos of pi minus alpha plus I sine pi minus alpha. Is that clear to you? So that becomes the solution. So the correct form in polar form or modulus argument form is always writing these with positive, right? So the argument takes care of the correct value. So I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.